Hello, everyone. Hope you are doing well in your studies. So here we are to do the another self-assessment test in P block elements. So this is the assessment test 5. 1, 2, 3 and 4 we have done in the previous lectures. So let us start to self-assessment test. So the first question is acidic strength order. Now this is a true and false type question. HClO, HBrO, HIO. All of you know well that the acidic strength is what? It is the release of H positive ion. When we will see the structure of HOCl, that will be in this manner. So the Cl is more electronegative in nature. So it will take the electrons from the oxygen, which will be more electronegative, which is the electronegative as compared to hydrogen. So the electron density will be moved towards the chlorine because of electronegative behavior. And because of that reason, it can release the H positive ion easily. So we can say that this statement is true and this is the statement assertion like assertion and this is the reason. So assertion reasoning type questions may be asked from true or false. Now the second question is stabilization of charge order. You can see easily that these are the oxo acids of chlorine that you have done in the 17 group element, that is HOCl, HOClO, HOClO2 and HOClO3. When you will remove the H positive ion, you will get the species ClO minus, ClO2 minus, ClO3 minus and ClO4 minus. Now charge stabilization is depending upon the number of oxygen atom. So when you will see the structure of these oxo acids, this is the structure of ClO4 minus. So you can see that this negative charge will be dispersed among the 4 oxygen atom. So you can say the answer for this question is A. That is the charge stabilization is more whenever the number of oxygen atoms are more. Now the question number 3. Dash is least stable. Now see the option I2, Cl2, Br2 and ICl. Now you can easily understand that ICl is the interhalogen compound and there is an electronegativity difference and the size difference between the I and Cl, so that they are having the low bond dissociation energy. So we can say that this is the least stable. All the halogens are stable as compared to interhalogen compound. Now the question number 4. It is interhalogen compounds are strong oxidizing agent. Strong oxidizing agent, interhalogen compounds. This is a true statement because they are consist of the halogens and halogens are the strong oxidizing agent because they need only one electron to complete the octet. Now the next question number 5 is shape of ClF3. Now you must know whenever you are going for the shape, you must know the number of bond pairs and number of lone pairs. So when you will see the ClF3, you will see that the ClF has the 7 valence electron. So the 3 bond pairs are there divided by 2. You will get 4 by 2. That is 2 lone pair of electrons and the 3 bond pair of electrons. So when you will see the shape of the ClF3, it is like this. And these two positions, equatorial positions, are occupied by the lone pair of electrons and the 3 positions are occupied by the fluorine. Now you can easily see that the shape of the ClF3 is the T shape, which is slightly bent towards like this. Bond angle is different than the normal trigonal bipyramidal shape, but the shape is T shape. So the option B is right for this question. Now see the question number 6. Dash neutral molecule is isoelectronic with ClO minus. This is the NCERT based question. ClO minus. Now you can see that the ClO minus में आपका Cl and O minus. O minus means that there is the element which has the 9 electrons because oxygen has the 8 electron. When the negative charge appear at the oxygen atom, it will become 9. So whenever we see the 9 in the periodic table, it is fluorine. So the answer ClF is very much right because the chlorine Cl and F, ClO minus has the same number of electrons because isoelectronic species are the species which has the same number of electrons. Now come to the question number 7. Oxidation state of Br in KBrO3 is. So we have to calculate the oxidation states, and when you will calculate the oxidation state, it comes out to be +5. You can find out very easily that potassium is the alkali metal which has the +1 oxidation state, plus bromine, that is X, you want to be calculate, and each oxygen atom will contain the -2 oxidation state, it is -6, and this is the molecule is neutral molecule, so it is equal to 0. So the oxidation state will comes out to be +5. The questions based on the oxidation states are very important this year for the MCQ point of view. Now the next question 8. 3Cl2 plus 6 NaOH gives 5 NaCl, NaClO3 plus 3 H2O. Is this reaction disproportionation reaction? You know well. The disproportionation reactions are the reactions in which the single element will exist in the more than three oxidation states. Means the single element will undergoes in the oxidation as well as in the reduction. So these are the disproportionation reaction. Now you can calculate, you have to be calculate the oxidation states of the element. Oxidation state of Na will remain the same because it is an alkali metal. It could be Na, that is a nothing is like that Na. So NaCl means +1 oxidation state for Na. Now you can see the Cl2, NaCl and NaClO3. Now here the Cl2 has a 0 oxidation state. In NaCl it has the -1 oxidation state. In NaCl O3 it has the +5 oxidation state. So this is the chlorine which has the 3 oxidation states, 0, -1 and +5 oxidation state. So you can see that it will fulfill the requirement for the disproportionation reaction, and we can say this is yes. So this can also be asked in the assertion reasoning type question or case study like question. Now the question number 9. Fluorine exhibit only one oxo acid, HOF. It is an assertion. You know well, fluorine does not has the vacant d orbital. So that we can say, and it also has the very small size and high electronegativity. Because of that reason, it only forms the one oxo acid. It is a reasoning type question. So this assertion is right. Now see the reason. Fluorine has small size and high electronegativity. Yes, we know that. Fluorine has the small size and high electronegativity. That is the reason is right. Means both the statements are right, assertion and reasoning. Now we have to see, is this justify this statement? Yes, we can say that this statement will justify the assertion because fluorine has the small size. It cannot extend its coordination number, or it has a high electronegativity. So it cannot be exist in the positive oxidation states. So it has only one oxo acid, that is HOF. So we can say that the A option is right. Assertion and reasoning both are right, and the reason will justify the assertion. Now the question number 10. Clf is a Lewis acid. Now Lewis acid, you know well, the acids which are electron deficient, but Cl and F both are the halogens and they have the lone pair of electrons. So we can say that these are not the Lewis acid, these are the Lewis bases. So you remember that interhalogen compounds are Lewis bases, not the Lewis acid. So this statement is false statement. Now see the question number 11. Now this is the question in which you have to give the answer of each of the part. Name the element of group 17. So you have to be concentrate on the fluorine, chlorine, bromine and iodine only. Then you have to write the answers, which has the following property. Highest electron affinity. Now the fluorine and chlorine, दोनों में confusion होगा. Most of the students will think about the fluorine, but the electron affinity of the chlorine is more because fluorine has the small size and it has the interelectronic repulsion. So the chlorine has the high electron affinity as compared to fluorine. Strongest oxidizing agent, yes, it is fluorine because of high hydration enthalpy and the low bond dissociation energy of F2 bond. Now the last one is highest melting point. Highest melting point is for the iodine because of the strong van der Waals forces. Now this was the self-assessment 5. Now we will see the self-assessment 6 in this lecture. Now self-assessment 6. Now see the question number 12. It is a continuation part of the self-assessment test 6. 5. Dash oxides of chlorine has +6 oxidation state. It is not oxidizing agent, +6 oxidation state. Oxidation state. So now all of you are very well know how to calculate the oxidation states. If you will calculate the oxidation states in all of them, you will see the answer B is right. So you have to be calculate and check your answer whether your answer is right or wrong. Now the question number 13. Among the hydrides of the halogen, which has hydrides of halogens are what? HF, HCl. आपको नाम से आपको पता होना चाहिए कि हम किसके बारे में बात कर रहे हैं. So we are talking about the hydrides of halogen. So we have to be concentrate on them only. Which has lowest boiling point? The lowest boiling point is of HCl because HF has the hydrogen bonding and HI has the strong van der Waals force because of the large size of iodine. And when we will see the order of the boiling point, the order of boiling point will be like this. That you have to be done in your lectures. So the HI has the, among all them, lowest boiling point. Lowest boiling point is of HCl. Another one is highest boiling point. From this order, you can easily find out which has the highest boiling point. So highest boiling point is of HF, and the reason is what? It is the hydrogen bonding. More acidic in nature. So more acidic in nature is which one? This is HI because of low bond dissociation energy between H and I. And last one is which one is most stable? So most stable is HF because of high bond dissociation energy. High bond dissociation energy. So for the boiling point, the reason is hydrogen bonding, and for the stability, the reason is bond dissociation energy. So remember this for the HF. Now the question number 14. In question number 14, we have to discuss about the type of hybridization in BRF5, BRF3 and IF7. So hybridization state, if you will be calculate, you will find that answer C is correct. So you have to be find out the hybridization for all of them. For that, you have to calculate the boiling point and the bond pair of electrons and the lone pair of electrons. In दोनों को add करके, then you have to find out the hybridization. Now the question number 17. Among the following pairs, which is more acidic in nature? So we have to be find out between the HF or HCl. Before that, we have discussed about the bond dissociation energy. So among the HF and HCl, HCl is more acidic in nature because of low bond dissociation energy. In the second one, HIO or HBRO. HBRO is more acidic in nature because bromine, Br, is more electronegative as compared to I. So that we have done in the self-assessment test 5 also, ki HClO will be more acidic in nature. Now, the HClO3 or HClO4. In HClO3 or HClO4, HClO4 will be more acidic in nature because more oxygen atom is here, and which is charge stabilization will be takes place after the removal of H positive ion. HI or HCl, you can easily find out that HI will be more acidic in nature because of low bond dissociation energy. HClO2 and HBRO2, HClO2 will be more acidic in nature because of the more electronegative chlorine atom. So this question is very much important, and that will contain the 5 questions. So you have to do more and more questions related to the acidic behavior of halogen especially. Now the question number 16. Dash has the highest electron affinity. This question will be asked in different forms. Electron affinity. So chlorine has the highest electron affinity. There is a confusion between fluorine and chlorine because fluorine is more electronegative in nature. Because of the small size, it has the interelectronic repulsion, so that the delta H gain will become less negative, so that chlorine will has the high electron affinity. Now the question number 17. Dash is true about the bond dissociation energy. Okay, which one is the bond dissociation energy? So if you will see, the bond dissociation energy will be depending upon the size. Fluorine, bromine and chlorine. Mostly the fluorine should be come here because FF bond will be more stronger because of the smaller size of F. But the fluorine has the small size and it has the interelectronic repulsion between the lone pair of electrons. Because of that reason, the fluorine has the less bond dissociation energy as compared to the Br2 and Cl2. Now the question number 18. It is an assertion type question, assertion reasoning type question. Here, assertion is HNO3 is stronger acid than HNO2. So assertion is right because in case of HNO3, the nitrogen has the +5 oxidation state. In case of HNO2, the nitrogen has the plus 3 oxidation state. So HNO3 is stronger acid because it has the more number of oxygen and more charge and dispersion is there. Now, what is the reason? Oxidation state of nitrogen in HNO2 is plus 5. That we have calculated already. So this is a wrong statement. So we can say assertion is true, but the reason is wrong. So question number 19. F2 is better oxidizing agent than Cl2. ये हमने अभी किया था कि F2 is better oxidizing agent than Cl2 because of small size and it has the less bond dissociation energy and it has the high hydration enthalpy. So we can say the statement is true. Now the last question for this assessment 6 is assertion is bleaching of flour by Cl2 is permanent while by SO2 is temporary. Yes, assertion is true. Because of what reason? कि Cl2 का जो assertion, जो Cl2 का bleaching action है, it is because of the oxidation. ये आपने को याद होना चाहिए और पता होना चाहिए because Cl2 when react with the water, it will result in the formation of 2HCl and produce oxygen. This oxygen is responsible for bleaching action. So the bleaching action of Cl2 is because of the oxygen, means oxidation. And bleaching action of SO2 is because of reduction. So now see what is the reason. Bleaching of Cl2 is by reduction. No, it is right. It is wrong statement because it is because of oxidation. So we can say कि assertion is true, but the wrong statement, wrong reasoning is given. The reverse is true for this. So we can say assertion is true, but the reason is wrong. So this is the assertion. This is the self-assessment test 6 for the P block element. Now the last self-assessment test for the P block element. First question is assertion reasoning type question. Now here we will discuss about noble gases forms complex with oxygen and fluorine. As you know well, noble gases has the fully filled orbital so that they will not gain the electron or lose the electron. Among the noble gases, only xenon has a tendency to form the complexes and the oxygen and fluorine are the electronegative element among the periodic table. So only these two elements are the elements which are electronegative and forms the complexes with noble gases like xenon. So we can say that this assertion is right. Now, reason. Noble gases have complete octet. The assertion and reasoning both are true. But the reason is oxygen and fluorine are more electronegative in nature. So this reason will not justify the assertion, that is the noble gases form complexes with oxygen and fluorine. So we can say the answer for this is B option will be right. Now the next question is hybridization of xenon in XeF2 and XeF4. So before calculating the hybridization, you should know the bond pair and lone pair of electrons first. So in XeF2, the bond pair of electron is 2 and the lone pair of electron is 3. So the total position occupied is 5. So the hybridization will be sp3d. And in XeF4, the bond pair of electrons are 4 and the lone pair of electrons are 2. So it is sp3d2. Now you will see which option is correct for this. Thus, this option is correct for the question number 2, that is XeF2 and XeF4. What is the hybridization of xenon? So in that manner, you have to calculate the hybridization not only for these compounds, for any kind of the compounds. Now the question number 3 is noble gas is abundant in atmosphere. Okay, which noble gas is abundant in the atmosphere? Among these options, the helium is abundant gas in the atmosphere. Noble gas is radioactive in nature. It is very simple question. Yes, it is radon, which is radioactive in nature. Now the question number 5 is hybridization of xenon in XeO3 and XeOF4. Now here the option C is correct. So you can easily find out for the XeO3 where one lone pair of electron is there and the 3 oxygen atoms are bonded with the pi bond. But the pi bond will not be included in the hybridization. So whenever you will form the structure for the XeO3, you will see 1, 2, 3, 4. So total 4 positions are there. So you can say the hybridization is sp3. Likewise, you can calculate for sp3d2 and sp3 XeOF4, which has the shape like this, one lone pair of electron, and this kind of the structure will be taken by this. So total 6 positions are there. The pi bond will not be included in the hybridization. Now in the question number 6, The noble gases compound prepared by the Bartlett was. This question is very important for the examination point of view also. It is XZPT F6. Question number 7. Dash has some metallic character. किसके अंदर आपका metallic character होता है? Among these compound, this is a 17 group element compound. So you can say this one is D because it has the large size and low ionization enthalpy. Now the question number 8 is, among the following XzO3, these are 3 compounds are given to you. These having the same number of lone pair of electrons of xenon. You have to calculate the number of electrons and you will find that D option is correct. So you have to find out the number of electrons, number of lone pair of electrons among these, which will be calculated by this. जो मैंने आपको पहले भी इन सब के बारे में समझाया है कि how can you calculate the number of lone pair of electrons. Question number 9, that is dash would have a permanent dipole moment. So SF4 molecule has the permanent dipole moment because it has this kind of the shape in which the lone pair of electrons will present in this manner, and it will be give the lone pair of electrons is present in this manner, and there is no cancellation for this dipole moment by the lone pair of electrons. So it has the permanent dipole moment. Now the question number 10. Helium is used in balloons in place of hydrogen because it is. Why it is so? कि हीलियम को बलून में, जो ऊपर उड़ने वाला बलून होता है, तो उसके अंदर किसको यूज हीलियम को यूज करते हैं इन प्लेस ऑफ हाइड्रोजन बिकॉज ऑफ इनकम्बस्टिबल इन नेचर. Hydrogen is highly combustible and it will be blast, so that it is helium is used in place of hydrogen. Now the question number 11 and the last question is, argon is used. Argon को कहाँ use किया जाता है? It is used in high temperature welding. So these questions you will find out from the uses of the noble gases. So now up to the self-assessment test 7, we have completed the P block element regarding the MCQ questions. So you have to do your questions and find your problems.